My name is Javier Salcedo Albarracin. I am an agricultural engineer by profession. I work here in Agrosavia, in the transitory network. In recent years, we have been working on precision agriculture here at the ZI Investigation Center La Libertad, on temporary crops in the region and supporting other networks, such as permanent ones. All this with our resources, which we have obtained through the products of the national agenda. Within these machines that we have and with which we have here, there is a hexacopter. This hexacopter is a piece of equipment developed by the University of San Buenaventura, specifically for research use. For us, in which a sensor is mounted, which is a multispectral MicroSense camera. The equipment has a double positioning system, one for the camera, the other for the machine. It is a machine with 6 tarot engines. On a board SIG hub, we have a gimbal system, which is to guarantee the stability of the images to be captured. As previously discussed, and within the spectrum, we handle the ball in this chamber. The 5 bands, which are red, blue, green, which are the common RGB that we find in our cameras, common devices. In addition to this, we have the red border, and we also have the REL. In this equipment, its bandwidths are very small, therefore, they guarantee a good calibration of the spectroradiometric part of the camera. In addition to this, we have another set of equipment. We use a field computer. This equipment has good resistance conditions, both for dust or rain, and it has a screen that allows us to work in high light conditions. It allows us to have an optimal brightness to be able to carry out the tasks. We use this equipment for different tasks. In this case, we use it as a flight station. We have control of 12 channels, with which we operate the equipment autonomously, or it can also be personally. It means that it is only manipulated by the pilot, or it can also be automatically, which makes the flight scheduled at the station. This is a calibration panel. This is the one we use to do the radiometric calibration of our images. It is a base for the subsequent exercise. In the photogrammetric software, to further improve this and reach a better calibration precision, the equipment has this DLC light sensor, which allows us to improve the calibration of each of the images during the flight. What we have there are targets, which we use in the field to perform orthocorrection for the geometry of the images and that are really well calibrated. This is then done with a shot, a survey, with the positioning systems we are talking about, which are in this case a Topcon brand RTK, with which we survey each of the points of control, and on this, the photogrammetry software, the correction and the geometry are made. We have in the team the software we make our flight plans. It is free software. It's called a mission planner. In this, we input a polygon of the area where we are going to intervene. With that polygon, we draw up a flight plan. The plan consists of flyings in the form of zigzag, in which the route is made, while the team takes the images, guaranteeing first a height that we have defined, overlap forward with the image and the sideways with the adjoining image. It tells us at once how long the flying time is going to be and what area we are going to cover. Also, it can give us suggestions about what the shutter speed of our sensor should be to guarantee these specifications that we have given. Once we have the flight plan ready, what's next is to give the signal to the team and load the flight plan. Then we only have the exercise of taking off and landing. All these images are captured in a memory, a micro SD. Then the images are taken to compose the mosaic in the photogrammetric software. We continue with the equipment used for the precision agriculture part. At this moment, we are with the global positioning systems that we use. Navigation systems in this case, we have an RTK system and a correction system at different times. How does each of these work? These are really similar to a GPS. GPS is one of the most varied navigation systems, as there are many constellations. We have the GLONASS, Veidu, and Galilea constellations, among others that are appearing, which are different teams of satellites in a group, which generate all the position information at the global level. This equipment we have here is a NET G3. It is a course. This is the one that we started using to make our survey for the georeferencing points, which is a team whose disadvantage at that moment or with it has at that time is that it needs to take the point and then make a differential correction. To make this differential correction, we have to resort to the data generated by the IGAC. The IGAC doesn't give us the values in real time. If we needed to go to the third day with that data, we will start our process. Later on, this equipment was acquired that performs the differential correction process in real time. That is, the point is ready to be used in the photogrammetric software, which we use to do the ortho rectification of our images. What does each one consist of? There are the base and the antenna, with which the signal from the satellites is captured. In the case of RTK, we have the base, which is the one that remains fixed, capturing the satellite information all that period of time during which we do our survey, and we have the rover, which is the equipment with which we are going to capture the points on the ground, the different points. Continuing then with the equipment, with them we can do 4 types of point information capture. The first is autonomously, that is, only with one of our teams. We go and capture. This would work like any of our GPS, with some significant errors, but they are useful for exploratory purposes. The other way is using it, as I mentioned, this one as a rover, and this one as a base, and an area is raised, if it is required to take more points and more area. These machines only have an approximate range of the potential of 1 kilometer. If we want to expand that radius of action, we use precisely this equipment, which is what allows us a radius with that amplitude, and it allows us to potentially work up to 20 kilometers. So that team is assembled and we have as a base our cars team, the net G3. And these two teams work as rovers. That is, we would already have two people working, with these teams raising the base and guaranteeing a sufficient distance. Those would be the ways how it can be used in the georeferencing part. When we need to do the survey for a flight carried out with our drones, then we use the field spots that we saw. On them, we take each of the points and these are entered into the photogrammetric software. It makes the correction in such a way that they remain in their position, both in X, in Y, and in Z, corrected with errors smaller than 2 centimeters, or between approximately 2 centimeters. That's all we have of this.